Greetings, students of Algebra 1. Mr. V here. Take you through another lesson. So today we're going to be talking about solving equations, one-step equations. So at the end of today's lesson, you'll be able to solve a one-step equation. We'll talk about what that means to solve. And you'll be able to explain what is a solution for a given equation. But first, let's brush up on what we learned yesterday. And as I go through these, you can pause the video and try to answer yourself. You can always test yourself. So what is a coefficient? Remember, a coefficient is a number that is in front of the variable. Right? Do you remember what we would call this when it has no variable? This is a constant. So any just straight up number without a variable, that's a constant. Any other constants? Now let's highlight them. Constant. Constant. Any other ones you see? Yep. 1.4. Those are all constants. And these don't have coefficients. Because remember, a coefficient is a number in front of a variable. So if there's no variable, it can't be a coefficient. So let's look at these other terms. Any variable term, these are all variable terms now. They all have some kind of variable. This guy's got a y. This guy's got x squared. So what are the coefficients? Well, the coefficients here would be a 5, 4, 12, 3, 1.4. This coefficient happens to be a fraction, which is 1/4, or 0.25. And this coefficient, 9.7. How about if I did this? Now what's his coefficient? Well, it's not 12 anymore. Now his coefficient is a -12. And if I were to get like terms, well, what are like terms? Like terms have the same variable. So are these like terms because they got the same variable? Well, that's only half of it. They got to have the same variable to the same exponent. Sometimes that's called a power. So he's to the power of 1, because when there's nothing there, it's actually a 1. So does that go with anybody? So I'm basically looking for ones that look alike. This one here, let's pretend it's a negative, so yep. Any other x terms we say? He's an x term. How about this? Is this guy an x term? Nope. He's an x squared term. So we'll get them next. He's an x squared. Any other x squareds? Yeah, there we go. 1/4 x squared. And finally, who can go with this one? Well, I'm looking for y terms, just a plain old y. Yep. So you notice, when we're finding like terms, the coefficient really doesn't matter at all. All we're looking at is the variable and the exponent. And then if we're going to combine like terms, that's when we start adding the coefficients, right? So if I combined a 5x and a -12x, what would that put me at? What is 5 added to a -12? Puts you at -7x. Okay. So we're going to be talking about solving equations. Very, very simple equations, simple as they get. But we need to understand the concept of an equation. An equation, just like it's got in the word, what's the root word of equation? Equal, right? Equal. So equations always have an equal sign. Okay? So it's always something is equal to something. That means that each side of the equation, so there's two sides of an equation, right? You got your equal sign. Sometimes you draw a line in the middle. And you say both sides are perfectly balanced, right? So this side is perfectly balanced with the right side. Okay, so what do you think? Looking at these two images here. Which one has two sides that are balanced? Well, obviously not this side. Would you think this one has more or less than this? Looks like this one's a little being pulled down more, so this one has a little bit more. So maybe if there was fruit in there or something like that, maybe this would be 5 pounds, and maybe this could be 4 pounds. Does 5 equal 4? No, it does not. So sometimes in math we say it does not equal. Okay, how about this one? Well, it looks like if there was 5 here, there would be 5 here. So an equation is a statement of equality, which means it's showing you that both sides are totally balanced. So usually when we're working with these equations, we're going to have some kind of variable. So that x that you usually deal with is some mystery number in disguise. So it's called a variable. We need to use our algebra skills to help find the missing number. Sometimes they are so easy we can use common sense to figure it out. Like, look at a simple equation. What if I had 5 plus x is equal to 7? I'm sure most of you can do this in your head. What mystery number can I substitute in for x to make 7? 5 plus what mystery number makes 7? Well, it has to be a 2. So, in this case, x would be a 2. This is called our solution. The solution, when you plug it back in, you get a true statement. So let's try it out. 5 plus, we just said x was 2. So this is a way we can check to make sure we got it right. Does 5 plus 2 equal 7? Does 7 equal 7? Yep. Okay, so the solution, when you substitute it back into the original problem, makes a true statement. But sometimes they're not always so easy, so we got to have some way to do this. So it says, do the opposite operation. So what are these operations? This is the operation of addition, subtraction, multiplication, and division. And I'm sure you've heard this before. The opposite of addition is, I'm sure you guessed it, subtraction. The opposite of subtraction is, of course, addition. The opposite of multiplication is division. And the opposite of division, of course, is multiplication. The rule is that whatever we do to one side, we have to do to both sides. Okay, so it says do the opposite operation to isolate the variable, to get x all by itself. Okay. When we're solving an equation, we're trying to get that variable all by itself. So the question is he all by itself right now? Is he the, sometimes I draw a line through this so it's nice and neat. Is that x all by itself on the left side of the equation? Well, no. Well, who's over there that has to go? That positive 3. So I always say do the opposite of what you see. This is a positive 3. What's the opposite of a positive 3? Negative 3. Now why would we do that? Because what is a 3 minus 3? It makes 0. And what's left over on the left side? X. So just by doing the opposite. Now I'm going to make a mistake. You try to tell me what it is. You say, oh, this has got to be a 12. Now, this was totally balanced. The left side was totally equal to the right side. And then I went and I did this to the left side. I took away 3. You can think about it like 3 pounds. I took away 3 pounds from the left. Now, if I take 3 pounds from the left, are we still going to be balanced on both sides? No. I need to do the same thing to both sides. So if I take away 3 here, I need to also take away 3 on this side. And then you, whatever the operation is. So here it's 12 minus 3. We know 12 minus 3 is 9. Now could I check my work to make sure I got it right? Well, let's find out. Let's plug it back in. Substitute it back in. That's a 9. We'd think it is. Is 9 plus 3 equal 12? Checks out. Okay, second one. I'm going to draw my line down the middle, stay nice and neat. I want to get this guy all by himself on the left hand side. Who is on the left side right now is trying to get away. I think about it like this. I want to get the variable by itself and it's on fire. Everyone's trying to get away, right? So some people try to move this 12 over here. Well, why would you do that? This x is on fire. Okay? He wants to be all by himself. Everybody's trying to get away. So this guy needs to get away. So we go with our rules. What is the opposite of a negative 3? That has to be a positive 3. Because what does negative 3 plus 3 make? Yep, 0. That's why we did it, to get rid of it. But if I'm adding 3 to the left side, I need to add 3 to the right side. Whatever you do on the left and right side has to be the same. Very, very important. Okay, what comes left? What's on the left side still? Still have the x. And what is 12 plus 3 on the right side? 15. Let's double check. Is 15 take away 3 12? Checks out. So that was addition and subtraction. How about multiplication and division? Now what does this say? If I were to ask you to read this, 3x equals 12, I'm sure most of you would say. Does anybody know what operation this is? Is that addition? Well, it's not addition, because if it was, you'd see a plus sign there. Is it subtraction? No. You would see a minus sign. Division? No, we would see something like this. So what's left over? What's our last operation? Multiplication. This says 3 times some mystery number equals 12. Other ways you could see it is with a little dot, or sometimes we use parentheses to show multiplication. Does anybody know why we wouldn't do this anymore? Why don't put it next there for multiplication? Well, now that we're starting to talk about variables, you can see how this for multiplication is going to get mixed up with a variable. So we're not going to be using x anymore for multiplication. But luckily for us, when you just smush a number, a coefficient right in front of your variable, we know it's multiplication. So this says 3 times x equals 12. Okay, do it in your head. 3 times what mystery number right here makes 12? Well, I'm sure you said 4, right? Because we all know 3 times 4 is 12. So, what if we used algebra skills though? What if we just didn't know that? Well, we know what operation we're trying to undo. We just talked about addition, subtraction. Now we're starting with multiplication. How do you undo multiplication? Well, we know the opposite is division. So the trick is you just divide by whatever your coefficient is here. So, divide by 3. Now, does anybody know why we would do that? Why would you divide by 3? Does that equal 0? If you went to your calculator, you typed in 3 divided by 3, what's it going to equal? 1. And isn't 1x just the same thing as x? So that's why we divide by that coefficient, because it's just going to make a 1. Now remember, whatever you do to the left side, you have to do to the right side. So what am I going to do to that 12? Also divide him by 3. So we just said the x comes down, equals what? Well, 12 divided by 3, just like we said before, has to be a 4. And let's go back and check it out. Let's plug it back in, substitute it back in. 3 times a 4, we think it is. Does that equal 12? 3 times 4 is 12. Checks out. And the last thing we're going to have to do is, this is a fraction bar. Sometimes it's called division bar. Okay, so this is, the operation here is division. This says x divided by 4 equals 12. We know the opposite of division is multiplication. So what we do is we multiply by whatever's on the bottom. Now why would we do that? Well, just look at this. What is 4 divided by 4? 1. Isn't 1 times x just x? Okay. Now I'm going to make a mistake. What did I do? Well, if I'm going to multiply this left side of the equation by a 4, what do I need to do to the right side of the equation? Also multiply it by 4. So 12 times 4 makes, what's that going to be? 48. Let's check it out. Is 48 divided by 4 12? Checks out. So these are very simple one-step equations. Okay, we're starting with the basics. So it says, for example 1, we subtracted 3 from both sides. You see here. In order to keep the equation balanced, we need to subtract 3 from, we subtracted from the left side, so to keep it balanced, we need to subtract it from the right side. So the big thing is, do the same thing on both sides. So why don't you pause the video? There's 4 problems here. I want you to try these out. So, what mystery number plus 5 equals 17? Some of you can do it in your head. If not, let's go through our process. The opposite of addition, because I want to get this out of here, is subtraction. Subtract that 5. What do I do to the right side? Subtract 5. So I get x is equal to 17 take away 5, 12. I want to get x by itself. How do I get rid of a negative 2? What's the opposite of a negative 2? Positive 2. What do I need to do to both sides? Add 2. So I'm getting x, equal sign comes down. 6 plus 2 is 8. What operation am I trying to undo or break? Well, that's multiplication, so I know I got to divide. What do I divide by? Would it make any sense to divide by a 10? Well, then I got 2 divided by 10 is 1/5. Now I got 1/5 x. Did that help me at all? No. So when you're confused about what you're trying to, here, what do you divide by? Do I divide by a 2 or a 10? We just got to use some common sense. Is dividing by 10 going to help you if you're trying to get this by itself? I mean, that's the whole point. What if you divide by that 2? 2 divided by 2 is 1. Now we got 1x. What do I need to do to the right side? Same thing, divide by 2. So I get x is equal to 10 divided by 2 is 5. I want to get x by itself. What operation am I trying to undo? This is division. How do I undo division? Multiplication. Now, would it make any sense to multiply by a 4? No. How about a 6? Okay, 6 divided by 6 is 1. So I just get x left over. But what do I need to do to the right side? If I multiply this side by a 6, I need to multiply by a 6. 6 times 4, 4 times 6 is 24. Okay, once again, if you notice with all these, doesn't matter what type it is, I'm always doing the same thing on both sides. You have to do it, otherwise, if you only do it on one side, you're not going to be balanced anymore. So how do you know, if I give you a number and I say, is this a solution, how would you know? So look at this one, 5 plus x equals 8. So if I said the solution was 4, which means x equals 4, right? I'm saying the solution is a number for x. So what would you say? Is 4 the solution? Well, you would say, let's try it out. 5 plus 4 is 9. Does 9 equal 8? Well, that doesn't make any sense. So I would say, nope, 4 is not a solution because when I substitute it in, I don't get a true statement. Okay? So that's the first way we can do it. Substitute it back in, see if you get both sides are balanced. If not, well, then you know it's not a solution. The other way is just to solve it on your own. Well, now we know how to do this. I want to get x by itself. How do we get rid of this? Well, first of all, is that a 5 or a negative 5? Right? Of course, you know that's a positive 5 right there. And what's the opposite of a positive 5? Negative 5. We're just trying to get this guy out of here. Now remember, what do? If you do it on the left side, you need to do the same thing on the right side. So if I get x is equal to 8 minus 5 makes a 3. So this is the second way we can do it. We can actually just solve it and see if we get the same answer as I said it was. So I said it was 4, and you say, nope. I used my algebra skills, and I found it to be a 3. Okay, here are a few problems. It says, tell me if I have given you the correct solution. Write true or false. Show me the math to prove it. So we can actually prove it. If I said the solution for this is 10, you should be able to prove it to me using one of those two methods. The first method is actually just to plug it back in and try. So 5 plus 10, we're going to try to figure out, does that equal 14? It's kind of like we're not sure yet. It's a question mark. Well, 5 plus 10 is 15. Does 15 equal 14? Oh, it does not equal. Does that mean there's no solution? No, it just means that 10 is not the solution. Okay? So what if I then said, so that's going to be a false, but what if I said, what is the solution? Well, then you're going to have to solve it yourself. How do you get rid of 5? We need to subtract 5 on both sides of the equation. How do you know where the left side ends and the right side begins? Well, it's always going to be right at the equal sign. That guy's gone. I get x is equal to 14 take away 5 is 9. Okay? Let's try this one. I'm just going to solve these now. That's 3 times x equals 18. How do I undo multiplication? Division. Do you think I should divide by a 3 or divide by an 18? Dividing by 18 wouldn't make any sense because I'm trying to get x by itself. Now I got a big mess over there. So let's divide both sides by the 3 because 3 divided by 3 is 1. That's what I want. So I get 1x, or x on the left side, is equal to 6. So that's going to be true. How about this one? Let's solve. So I get x. Well, how do we do here? Add 4 on both sides. That's 0. So x equals 10 plus 4 is 14. Yep, that's true. And solving this one, I want to undo division. So I know it's multiplication. So what do you think? Multiply both sides by 5 or multiply both sides by 3? So whenever you're in doubt, when you're trying to get rid of the thing on the left side or on the with the variable, you could almost cover up the other side. So that's got nothing to do with it. We're trying to get that variable by itself, so we're just dealing with the stuff that's over there already. Okay. Multiply by 5, so I'm getting x is equal to 15. No, it's wrong. False. And I just proved it right there. Alright kids, that's it for today. Have a great one.